In Chapter 4, we're going to look at designing studies, and in Section 1, we're going to talk about basic ideas when we sample and the good kinds of sampling. Okay, in sampling basics, the first thing you got to know is that the population in a statistical study is the entire group of the individuals that you want information about. Now, it's not always feasible to get to every member of the population, so we have to take a sample, which is just a subset of individuals in that population from which we collect the data. Now, a census, or the samples should be small, but a good representation of the population. Like, it has to be a mini version. It has to be unbiased. It has to be representative of the whole population to be a good sample. And that's a lot about what we're going to talk about in this section. Now, you may have heard of this. A census collects data from every single individual in the population. Well, it's not really going to happen. It's ideal, but it's not convenient, and it's not always possible. Even the U.S. Census doesn't get to every single individual. They have to beg and plead people to complete it, and they may or may not. It's their choice. So a census is an idea of how we could get to every member of the population, but it's not always successful. So we end up really having to take really good samples to be able to represent our population. So in this, just a couple examples, we want to identify the population and the sample in each of the following settings. The student government at a high school surveys 100 students to get their opinions about a change to the bell schedule. Well, you've got to think about it. The 100 students is the subset of a bigger population. So we have to think of what is that bigger population? Well, that's all the high school students. The entire high school student body is our population. The sample is the 100 students that were surveyed. And a lot of times when you approach these problems, it's easier to see what the sample was, and then you have to broaden your thoughts as to what that population was. So look at B. The quality control manager at a bottling company selects 10 cans from the production line every hour to see whether the volume of soda is within acceptable limits. Well, if the sample's these 10 cans, what's the population? Well, it has to be all the cans produced in that hour. All the cans produced in that given hour. And then the sample is the 10 specific cans that were selected in the same hour. Okay, the phrase "in that hour" is important because we're not looking at all cans all day. We're just looking at that one given hour. All right, so there are some good samples and there are some bad sampling methods. So we're going to first look at just good random sampling methods. So a simple random sample, we often abbreviate that SRS, of size n is chosen in such a way that every group of n individuals in the population has an equal chance to be selected as that sample. Okay, so it's important that whatever the size of it is, that every group of that same size has an equal chance. I know that feels redundant, but that's an important characteristic to make it a simple random sample. So let's look at this example. Say a high school has a population with 200 female students and 300 male students. If they number all the students and use a number generator to sample 20 females and 30 males, does this constitute a simple random sample? Well, does every sample have the same chance of getting 20 females and 30 males? No. Each person has a 1 out of 10 chance of being selected, but not every group of 50 has an equal chance. For a simple random sample, it should be possible to sample 50 girls, for example. Like, you would have to simplify this down to gender, male and female, before you do your sampling. Otherwise, the male and females do not have the equal chance of being selected. So on a simple random sample, that's a very generalized version of what we're looking for. But there are some more specific, clear ways to do this. So the first one I want to talk about is what we call So simple random sampling is a very general method, and there are some more specific good random sampling methods to look at. The first one we want to look at is what we call this stratified random sample. And what you do is you start by classifying the population into groups of similar individuals, called strata. And then you choose a separate simple random sample in each of the stratum and combine these simple random samples to form the overall sample. That way, each strata has an equal chance of getting chosen. All right, so here we go. Let's look at this. Here's a football stadium. we want to see what the average price of a ticket is for this game. Describe how to make a stratified random sample. So the first thing is we've got to identify, what is the strata? Well, in this case, let's look at our strata as each of the 4 levels of seating, because each level has a different price. If we're looking at the average price of the ticket, we know that the tickets that are closer to the floor, or maybe even on the floor, are most expensive, and the nosebleeds are least expensive. You know that from experience. So that would make sense to make each level a different strata. So that's what I'm going to do. Each strata is going to have a sample taken. So I'm going to take 50 people from each strata here and combine those 50 people for my overall random sample. So when you think stratified random sample, we are taking some from all the sections. We've divided it into sections and we've taken some from all. And that's important when you have the next one in mind, the next kind of method. Sometimes they get confused, but what you have to remember with stratified is that it's sum from all. Another good random sampling method is what we call a cluster. It's called a cluster sample. And we start by classifying the population into groups of individuals that are located near each other. That's what's different about this and stratified. Stratified is grouped by characteristics. Cluster is grouped by location. So these individuals are near each other and we call them clusters. And each cluster basically needs to represent the population, like a mini version of population. Once you've identified your cluster, you choose a simple random sample of the clusters. You pick which cluster you want to choose, and then you survey all the individuals in that chosen cluster. Okay? So again, if we talk about this football stadium, how could we get a good sample random sample, but this time using clustering? Well, you would cluster by sections. Okay? If I numbered my sections 1 to 12, you can see that I'm going to capture each row, first, second, third, fourth row up, in each of those clusters. So I'm going to get a good cross-section of all ticket prices if I take one of these. So I've numbered them, and then what I would need to do is take a simple random sample and decide which one of the 12 am I going to use. And then I sample every single person in that cluster. Okay, so with cluster sample, you take everyone from one section, or all from one. Remember, stratified sampling was sum from all. That's how they're different. So we will do some demos of this in class also, but that's basically the catchphrase. We sample everyone from one section with cluster. All right, the last type of good sampling method I want to bring up to you is what we call a systematic sample. And we use a random number generator to choose a starting number, and then you add n to each previous number to find the individuals to make up that sample. Like, say I randomly chose a number 4, and I add 10 to it. So my first choice is number 4, the next one is 14, the next one is 24, 34. So there's a system to it, but you have to be clear on how you do this. It can be a little tricky. So let's look at this. For 200 movies, if I want to sample 10 movies, I'm going to use a random number generator to get a starting number from 1 to 20. Okay, I'm dividing 200 by 10 to give me 20. So I use a random number generator to help me pick my first number. Let's say I got a 16. So the sample, I'm just going to be adding 20 each time to get to all 200 movies. So I would choose number 16, number 36, number 56, 76, and on and on and on. I'm going up by 20s, all right? So systematic sample is one way to do a good random sample. It's borderline good. It's not the greatest, okay? We call it sometimes a convenience sample because it doesn't guarantee a representative sample from the population. It's sometimes better than nothing, but a convenience sample is one of the bad random sampling methods we're going to discuss in a future video. But this is almost convenient, but there is some system to it that helps it be a little more random than just a generic convenience sample.